Hello everyone. Today we are going to solve one more question from statistical mechanics and let us read the question and solve this one by one. The question is this is the quantum energy level of a rigid rotator, that is the rotational energy. As you know, the rotational energy is j square by 2I, and I is the moment of inertia, that is ma square, and j is equal to j plus 1 h cut root. So from this that rotational energy is given. Then where j is equal to ranging from 0 to m, and a is a positive constant, and the degeneracy of the level is 2j plus 1 is given. And then we have to find out the general expression for the partition function. Okay, as you know, the partition function is sum over g e to the power minus beta e. So put the thing, that is z0 is equal to sum over j ranging from 0 to infinite, and 2j plus 1 e to the power minus beta is 1 by kt, and energy is given as j plus 1 h square by 8 pi square m square. For the sake of convenience, let theta is equal to h square by 8 pi square m square k. Then that term will reduce, then it will be 2j plus 1 and e to the power minus theta j plus 1 by t. Okay, this is the partition function of the rigid rotator. Okay, then what will be the next question? What is the next question? The next question is, so that at high temperature it can be approximated by an integral. Okay, so at high temperature, that means t tends to infinite, our beta tends to 0. Okay, when t tends to infinite, theta by t will be much less than 1. Okay, then e to the power minus theta j plus 1 by t, that is the exponential term, will changes slowly as j changes. Okay, that j, so we can approximate as 2j plus 1 e to the power minus theta j plus 1 by t, a continuous function of j. Continuous function of j. So then suppose x is equal to j plus 1, then dx will be 2j plus 1. Okay, so when t tends to infinite, our partition function can be obtained by integration method. Okay, it is integration of 0 to infinite e to the power minus theta x by t into dx, as this term is dx. Okay, if you do the integration, the value will be t by theta. T by theta. Okay, if you put the values of theta, then partition function will be, put the values of theta, partition function will be t by 8 pi square m square k by h square, if you write it as in form of I 2I kt by h square is the partition function. Okay, this is the answer of question B. And then question C is given that we have to find out the internal energy, the mean energy. So mean energy is equal to minus del by del beta of ln z. So if you write it in terms of beta, then 2I by beta h square, as beta is equal to 1 by kt, you know. Okay, so minus del by del beta of ln 2I by beta h square is equal to 1 by 2I by beta h square into 2I by h square, and the derivation of beta will be minus 1 by beta square. This will be cancelled, then that will be 1 by beta, that means kt. Kt is the mean energy when t tending to infinite. Okay, and you know the specific heat will be del u by del t, that will be k. K is the Boltzmann constant. Okay, then let's go to the question number D. What is the question D? Question D is find the partition function C, Cv and U at low temperature. Okay, at T tends to 0, that is the low temperature, beta tends to infinite. Okay, at low temperature, what will be the thing? Our partition function is see here, the partition function is 2j plus 1 e to power minus theta j plus 1 by t. Okay, keep in mind, then go to the thing that theta by t will be much greater than 1, that means temperature is much less than theta. So our exponential e to power minus theta j plus 1 by t will be, we can expand it. Okay, so partition function will be sum over j is equal to 0 to infinite 2j plus 1 e to power minus beta j plus 1 its square by 2I. Here I am taking the energy into j plus 1 its square by 2I. Okay, I am not h cut square. I am not writing it h cut as h by 2 pi. So like this, then put the value of j is equal to 0, then the exponential will be 1, so total will be 1 plus, then put value of oj is equal to 1, then that will be 3 e to power minus 2 beta j 2 h cut square by 2I, and this will be cancelled. And then so on terms will come, 1 plus 3 e to power minus beta h cut square by 2I, and plus dot dot dot, like this terms will appear. Okay, then we can find out the free energy. Free energy as well. Free energy is equal to F is equal to minus nkt ln z, and as the at low temperature minus nkt, the first two term will take, then ln 1 plus 3 e to power minus beta h cut square by 2I, that is ln 1 plus x will be x. Okay, nearly equal to x, so that will be minus nkt 3 nkt e to power minus beta. beta h cut square by 2. The 2 gets cancelled here, 2 will not remain, that will be I. Okay, it is the answer. You can find out a mean energy. I am taking a first two term because the temperature is very low, so the further terms will not taken. So energy is equal to minus del by del beta of ln z. So minus del by del beta of ln z is equal to ln 1 plus 3 e to power minus beta h cut square by I, and do the simple derivative. We will get the desired result as 1 by 1 plus 3 e to power minus beta h cut square by I, and here the things will come that 3 h cut square e to power minus beta h cut square by I, and I will come denominator part. Then you can find out the Cp as del U by del T. Convert beta to 1 by kt or T to beta, then you will find that Cp will be Cp will be 3 h cut square divided by k t square I square, sorry, h cut to the 4 at power 4 e to power minus beta h cut square by I, and not minus, it's plus, then it to power beta h cut square by I plus 3 whole square. Okay, do the simple derivative. I am not doing that, it's very lengthy, not lengthy, video will be length. So thank you. This is the most probable question for CSI net. Thank you for your patience to keep watching until the end. Thank you.